Welcome to this session on GSR 352, the batch API. My name is David Delabassé. I work at Oracle in the Java EE engineering group, and I'm basically an evangelist in that group. My name sounds a bit French, but I'm not French. I'm from Belgium.
Hey guys, I'm Roberto Cortez. I work as a freelancer in Portugal in a lot of markets like finance, health, and insurance. And it's a pleasure to be here first time in Devox Paris. Are you ready? So guys, most of you probably were wondering what batch is, right? So if you go and search for a definition of batch, you're probably going to find something like a group of records processes a single unit without input from a user, right? But let's try to make some sense out of it and see in much more detail what this brings you. If you look at it in a computer way perspective, we usually want to use batch to make use of the idle resources of our machines. Probably, let's try to make some things of the audience here. Who use batch on their daily job? Yeah, probably 90% of the room or something. So most of you probably also use batch during night when you do those really big, long processes that are running at midnight or 1 or 2 a.m. Am I correct? Yeah, and usually do that because you want to use of the idle resources that you have on your machines, because they usually during that period they are not occupied with something. So we really want to do this to use that computer power that's available for us, but it's just there wasted, and that's why you want to use it at that time. Also, we do this to shift the time of processing. One of the things we do this at night is because during the day, the users are heavily using our applications because that's their work time. They are hammering our databases, they are hammering our applications, and if we try to put like run-long in processes that consume a lot of resources, you're going to see a decay and a huge delay on the user experience, and we don't want that. So that's also one of the things we do to put those running processes running on that time. On another perspective, this also allows you to help to repeat those really long queues that we have, and this also helps us to manage those really large batch applications that we have. So that's one of the main reasons that we usually do that in that particular period. Another thing is we share this by multiple users. I mean, most of us have like, I don't know, a couple of hundreds, a couple of thousands computers available in our infrastructure, with all those users that just use them to like do some spreadsheets or send some email. It's just like some power waiting there to be used for our really long processing jobs that we really need to use. But this is on the computer perspective. Did you think about why we really need to do this? One of the things, of course, is efficiency. I mean, just think about when we want to do something, it's more efficient if you do it in a more repeatable way. Just like we can cache stuff, computer resources are available for us to use whenever we want, and it's more easy to use if they're already there, and we can use them right away. We also focus on a single problem. Remember when I told you that we're not sharing resources, so we focus on that particular problem, and we can figure out a way to do things more efficiently when focusing only on a batch processing way. Also, we're avoiding the context switch. And that happens to all of you, right? If we are working several things at the same time, we're not going to be more efficient. Of course, on the computer side, it's exactly the same thing, because you're not going to be able to cache some of the stuff you're going to be using. Probably not going to be sharing the same resources. You're probably going to have to like query something on some REST service, then a database, and so on. So you're not, when you're doing something in batch, you want to be very efficient, and you don't want to avoid those context switching. So it's much more efficient to do those things in batch. And of course, you want to reduce the cost of doing all these things. If you already have the manpower or the computer power to do it, you can do it by using the power that's already available to you, and you don't have to spin up other resources to do it. But I also want us to think about this. Batch is also present in our current lives. I'm talking of myself here, but whenever I pay bills, and most of us have to pay bills, I usually don't wait for like a bill to come and then I pay it, and then wait for another bill to come and then I pay it. For instance, the phone bill or the cable bill or the electricity bill. I just wait for all of them to come and then I pay them in a batch style. Who does this? Not so many, probably like 10 or something, but in my opinion, I do this because this is more efficient to do it in a way because I'm focusing on what I'm doing instead of like having to wait for something and so on. But think about groceries. When you go shopping for a grocery, you just don't go there and buy like an apple, then go home, put the apple in the refrigerator or something, go again, pick like a toothbrush, go again home, and so on. So you go there, pick up a cart, and then you fill up the cart wherever you need, and then go home and put the groceries away. So who does this? Yeah, everyone, because it's like a batch. So you like buying a batch of groceries, and you're doing it in a more efficient way. The same thing as traffic. When you see the traffic lights, you're going to see a lot of cars passing when you have a green light, and you see that's like a time frame when the cars are going to spin or going to move. And you're going to see the traffic lights are going to only allow only one car to go. No, they allow like 10 or 15 or 20 cars to go because it's more efficient that way. And anyone heard about the phrase or the sentence, I'm going to bake a batch of cookies? No? Batch of cookies doesn't ring a bell? Well, that's batch, right? You're going to bake a pastry, you're going to put it in the oven, and you're going to make a batch of cookies. You're not going to bake only one, because you're going to already spend all the resources that you have, like baking the pastry, putting it in the oven. I mean, the oven is already there, so you might as well, instead of doing one cookie, you might as well do 10 or 12 or 15, because it's more efficient that way. Now, looking a little bit into what we have here, I want to speak to you about the state of the art. So before going deeper into the JSR 352, let's see what we had before. So Spring Batch is mostly one of the well-known batch implementations out there. So who uses or knows about Spring Batch? Okay, yeah, probably like half the room or a little bit higher. Then there are other options like IBM WebSphere also has a solution for it. So who uses? Just one guy? 2 or 3? Okay, I'm sorry for you guys. Hopefully you can improve after this session about that. Then we have Hadoop. Who uses Hadoop here? I have like a couple as well. And then as a freelancer, I go for a lot of clients and a lot of projects, and I usually see a lot of these, like in-house frameworks using plain Java SE or scheduling, like crontab or something else. Who has kinds of this? Okay. Yeah, so like half the room. And this pains me a lot because since I do a lot of context switching between clients, then I pretty much have to relearn everything again when I want to do batch. Isn't that a pain, David?
Yeah, it is. I mean, so this is really what we will talk about. So JSR 352 is really about having a solution, so an API that allows you to easily develop batch jobs and run them on top of Java EE. The big difference between all those approaches is that JSR 352 is standard-based. So that means that once you use that API, you can use any underlying implementation. And for example, you will see that Spring Batch has been influential in the definition of the specification. So you can use JSR 352 and using the standard JSR 352. Sorry, you can use Spring Batch with with an underlying solution such as Spring Batch or any other solution. So that's really the benefit of that approach.
Yeah, awesome. So going to the JSR 352, so this is actually heavily inspired by the Spring Batch. Actually, if you're going to see some diagrams, the guys that are already using Spring Batch, the diagrams they're going to see here are exactly the same because they actually were copied from the Spring Batch documentation and we actually put it in the JSR 352 documentation. It was fun because this was probably one of the first times that the Spring guys contribute stuff to the Java EE environment. So we want to welcome more contribution from them. Is that right?
Yeah, that's correct. So something important to mention as well is that GSR has been led by IBM. So IBM has been leading the definition of that specification. And as Roberto mentioned, if you look at the specification, some of the diagrams used are coming directly from the Spring Batch documentation. So clearly, Pivotal has also been very influential and involved in the specification. So it's really the value of a standard. It's basically everybody agree on how we should do batch in a standard way.
Yeah, that's awesome. Anyway, it's available since Java E7. So who's still using Java E7? Just a couple of guys. So this is time for you guys to upgrade. And yeah, I know sometimes it's not easy, but I mean, here you have a reason to do it. But don't despair because it's also available for plain Java SE. So if you're not using a Java E7 environment, you can still use JSR 352 in the standard edition environment. So it's a good thing that way.
But obviously, if you use JSR 352 in a Java EE context, you would benefit basically from the complete Java EE environment. So, for example, transaction, those kind of things that are provided by Java EE.
Yes. So let's have a look in some of the main features of the JSR 352. So for the guys that are already into Spring Batch, some of this stuff are not new. So of course, you're going to have a task and chunk-oriented processing. We're going to have a look into more detail in a while. We can also execute our batches in a sequential or in a parallel way, which is a great thing. We also have a workflow where we can define on how we want to do our batch processing using an XML file. So this is quite boring, but let's see if we can improve this in the new specification. You can also have all the things that you can do it with Spring Batch, like you can stop, you can restart, you can do checkpointing the records you're processing, which is quite nice. And of course, you also have a good way of doing exception handling, and you can actually decide on what you want to do when sometimes happens on your processing of a file or processing of records of a database and so on. So for you two guys to see, these are the diagrams that me and David were mentioning. Basically, this is the usual diagram that you have the Spring Batch, and now we also have it on the JSR 352. So usually we have like something called a job repository, which acts like a metadata where all the job information is going to be stored. Then you have something called job operator, which is an object that you're going to use to access your jobs. And then you have one job. That job has multiple steps, and then depending on the step, but usually the step you're going to probably use the most is the chunk-oriented style. You're going to have something called an item reader, an item processor, and an item writer.
Just one comment on that slide. So, there's something which is a bit misleading, job repository. So the specification talks about a job repository where we store metadata, but the spec doesn't really say about what the job repository should be. I mean, it's up to the implementer to decide if you want to use a database or if you want to use something else. But at the end of the day, for you, the developer, it doesn't matter. You know that there is a place where you will be able to access the metadata of the jobs. So it's fully transparent for you.
Yes. Then looking a little bit into more detail of the job. So a job is something a little bit abstract. You actually need to have some kind of representation of it. And that representation is called a job instance. And that job instance might have multiple job executions. So actually have a job, have multiple job instances, and then job instance have multiple job executions. And you can have multiple job executions. For instance, if you stop the job, then restart the job, stop, start, and so on. And the same for step. So a job has multiple steps, and the step might have multiple step executions.
And obviously, so you will have multiple job execution because we are talking about processing large volume of data. So your job at some point in time might fail. So that's why you also need the ability to restart a failed job.
Yeah. Anyway, I think it's very easy to start a GSR352 app, and David's going to show you how.
Yeah. So this is really the hello world of GSR352. So you know, in the Java world, we have these tendencies to put at the end of every word a let. So in GSR352, we have batch let. So this is a batch let. So how should I write a batch let? Well, it's very easy. So you just have to extend this abstract batch let. And then you override you provide the implementation of the process method. So that's basically what that is the core of your batchlet. I will explain a bit later on what a batchlet is exactly, but you see that it's fairly easy to do. Notice that we are also used the @named annotation so that we can easily reuse that batchlet later on. Also, you see that the batchlet is returning some kind of status. So that's something that we would be able to leverage to know exactly what was the status of that batchlet. Has it worked, has it failed, or something else?
Yeah, so just like an additional detail, what you have here, the things that you have in red are the ones from the batch API on the code. So as you can see, all the rest is standard API. Only the abstract batchlet and the batch status is from the batch API.
So now we have the batchlet. We need to define what a job is. So for that, GSR352 provide a DSL which is based, a specific DSL which is based on XML. It's called GSL, Job Specification Language. So we can see that IBM was involved because it's XML based. So this is a definition of a very simple job. So I have a job whose ID is my first batch. Then I need obviously to have steps in my job. A job without steps doesn't make any sense. So I need to have one or more steps. So in this case, I will just have one step. It's called my first step. And in this particular case, it's a batchlet. So batchlet, and then I give a reference to my batchlet, which in fact corresponds to the guy we have just written. So GSR352 basically give you the Java API and that XML based language to define your jobs. So we have that. Now what we need to do, we need to actually start the job. So for that, you might remember one of the earlier slides, we had this diagram with the job repository, and we had what was called by the specification the job operator. Again, the name is a bit misleading because the job operator is really an API that you can use to control your job. So you can use the job operator API to start a job, also to stop a job, to get the status of a job, and so on. So how it works? So you see, I need to have an instance of a job operator that I get through the batch runtime, fairly easy. Then I specify that I want to start my job. So I'm using that instance, the start method. I specify which GSL need to be used. So this is my first job is basically the XML file that is defining my job. And then I also have the ability to pass it some parameters. And what I get in return is an execution ID. So something that I will be able to use. Well, first I need that execution ID to actually start the job. So that's no, sorry, my job is already started. So once I have that, I have the execution ID, and I will be able to use that execution ID through the life cycle of the application to see, for example, if the job is still running, if it's stopped, and so on. So I've mentioned batchlet. So in GSR352, there are two kinds of steps. We have batchlets and we have chunk steps. So batchlet is really for what we call task-oriented steps. So basically, any steps that is not really working on data. So it's suitable for short execution, for working with system resources, for initializing stuff, doing cleanups. A good example, so let's say you have a batch that is running through the night. At the end of the batch jobs, you need, for example, to take the result, sign it, and put it somewhere in a data warehouse. So that final steps is really something that is not specific to any data. That's something that you have to do anyway. So for that kind of steps, you would use a batchlet. On the other hand, we also have chunk. And clearly, most of your job will use chunk steps. So chunk steps are using the ETL pattern. So we load something, we do some processing on it, and then we write the result. So suitable for handling large amount of data. The nice thing, obviously, about chunk step is that it has some mechanism to do failover. So we have the notion of checkpoint. So let's see, I think it's explained here. So this is a step. Yeah, I just forgot to mention something. So I said that the chunk is using the ETL pattern. So for each chunk step, we'll have a reader, a processor, and a writer. Well, we need to have at least a reader, and we need to have at least a writer. So the processor is optional, but obviously, if you read something, it's because you want to do some processing. So most of the time, you will have a processor as well. So reader mandatory, processor optional, but in most of the case, you will use and have one. And then you have a writer. So the checkpoint is basically allows you to do the following. Because writing the result is an expensive operation. So you don't want to do that all the time. So how it works, for a chunk step, you define a checkpoint. It's basically an interval. So in this case, I have a checkpoint of 2. So what my chunk step does, in that case, it reads something, it does the processing on that data, it reads something else, it does the processing. So we have 2 iterations, then we have a checkpoint. So that means that we can write the result. So at that point in time, you will, for example, so you will write the result, but you will handle the transaction, those kind of things. So this is particularly useful if your job fails. So because GSR 352 allows you to restart a job from the last known successful checkpoint. So we saw how to define a batchlet step. Now let's see how we define a chunk step. So it's very similar. So it's a step whose ID is my chunk. So now it's a chunk step. We define a checkpoint policy, and the item count is 3. So in this case, we will read, do the processing 3 times, and then we will write the output. We obviously need to define a reader. So that's what we do here. We have a processor, and we also need a writer, obviously, to write the output result. So that's the only thing we have to do. So I have a chunk step. Obviously, I need to define that chunk step in a global job. Then I need to implement it. I need to write the implementation of the reader, the processor, and the writer. That's what we do here. So this is a reader. So we just extend abstract item reader that is provided by the GSR 352 API. And we provide an implementation of read item. So that's basically where we will, for example, go to the database to read something out of it.
Yeah, one additional thing. So for the item reader, as well for the item writer, as you're going to see next, we're extending something here, but you also implement something called the item reader, because the abstract item writer gives you empty implementations for the read item. You also have other methods that you can override or implement, like open, close, and on checkpoint, which means that whenever the item reader is open, you can do something, and when it's closed, you can do something else. And on checkpoint is if you want to do some additional logic when the checkpoint happens on the chunk processing.
So we have the reader, now we need a processor to actually work on the data we have read. So it's exactly the same approach. So in this case, we implement the item processor, and we have this method process item where basically the processing will happen. So that's basically where we will write the code that needs to work on the data. And obviously, we want to have some output. So we need an item writer. So as we did for the reader, we will do it also for the writer. So it's exactly the same approach. So we have the GSL, we have the implementation of the reader, the processor, and the writer. So we would need to basically use the job operator to start our job.
Okay. So now sometimes we have to handle exceptions, right? I mean, whoever have any problems with batch running in the night, like records failing, all of these things happen, right? So we actually need to have some kind of way to handle those kind of problems. So every time you get an exception, the job execution will fail. But you can actually skip or retry those exceptions when you're reading the records or when you're processing those kind of records. It's only applied to chunk, of course, and you can include or exclude the exceptions you want to retry or skip. So let's have an example here. So this is a little bit complicated. Don't worry about the part of the reader, processor, and the writer, which is the same that was of the chunk. It's just to have the full sample here. But what we're doing here is we want to skip every runtime exception that's in here, and we want to retry when you get an illegal argument exception. And if you look on top of the definition, you also see a skip limit and a retry limit. So what's going to happen is we're going to skip that exception 3 times, and if we for some reason have a 4th exception, then the job will fail. Same thing for retry. So we're going to retry the exception 3 times, and if you have a 4th time, you're going to fail the job. And of course, the exceptions are polymorphic and are going to accept every subclass of runtime or illegal argument exception. Now, one of the things that is very interesting about JSR 352 is the ability to partition jobs. Sometimes we're dealing with so much data that we want to have a way to treat or to process data in multiple data at the same time. So basically, we can tell the JSR32 API to run the steps on multiple threads. Basically, it works 1 partition per thread, and we can have the partitions that we want. We just need to define them using the partition plan. The checkpointing, as David mentioned, for the chunk processing is also independent per partition and per thread. So let's have an example here. So basically, a partition is defined using this XML here. Now we're defining only 2 partitions, and we're saying properties for partition 0 is property start with value 1, and another partition with a value 11. Basically, what you're going to do is then you can pick up these properties, inject them on your reader or processor or writer, and then you can read these elements and try to do something with it. So basically, for instance, think that you're doing a query to a database. You can pretty much have some kind of property here that allows you to partition the data as you have it on the database. And when you're doing the reading, you can, for instance, read by age or by sex or something, some other particular property that you can use to distinguish your data and be able to partition it to have it processed in multiple threads. And we're going to see an example in a while, a real life one. Then to actually pass that partition property, use the same thing as definition that we had on the chunk. You pass a property there, and what's going to happen is the batch API is going to read this, going to start 2 instances of the item reader, each one instantiated with a different property that we defined in the last slide. So one reader with the start value of 1, and another reader with the start value of 11. So let's go to a very quick demo. Let's hope that the gods are merciful and this works. So please pray with me. Does anyone know what this is? Does anyone recognize this image? A couple of people. So this is actually from a game called World of Warcraft. Does anyone know, ever heard about World of Warcraft before? Yeah, most of the room.
It's a real world example. I mean.
Yeah. So as you probably figured out, I'm an addicted gamer. I don't play World of Warcraft that much anymore, but I did play it for a long while. And basically, for the guys who don't know what World of Warcraft is a massive multiplayer game. It has more than 500 servers between Europe and US. And basically, the game has something called an auction house, so you can pretty much think about it as like an eBay, where you can trade items in the game, sell them, and so on, sell, buy. And basically, the last statistic I got from there is that all these servers of World of Warcraft, they trade around 70K items per server per hour, and that's around 35 million items in total per hour. Another interesting thing is that all this data is actually available for download. If you have no idea, you can actually download this data. So that when I was searching for something to include on this presentation, I mean, let's be honest. Batch is pretty boring stuff, right? Who agrees with me? Yeah, most of us, yeah. So I didn't want to come here and do some very boring example like some stock, whatever, or some financial transactions, because you probably already have all of that in your daily life. And so I tried to come up with a funnier example where people can be interested in looking. So this action data that I've talked to you about is actually available at Blizzard sites to download. So Blizzard is the maker of the game. So we can actually pick it up, process the data, and try to extract some metrics. So basically, I actually implemented an application here to do that, and then tells me like the variation of the prices of an item, so I can see if the price is going up or down from that item, so I can go and sell it or buy it or something else. So let's switch here to my IDE to show some code. Can you guys read the code? Yeah? No. Anyone? Can anyone not read the code? Okay, awesome. So, yeah, let's start with the simple one. So what I have here is an XML definition for something called a load realm auction file. So what this does is going to go to the World of Warcraft servers, download the files that are on each server. Actually, just going to query for the file, and I'm going to create a record in my local database, so I can see then if I need to download the file and process the data that it is in. And anyways, you can see this is a good example of when to use the partitioning. Why? Because I have servers on Europe and I have servers on US. So what I'm doing here, I'm going to create a partition for region, which is the US one. And this is the URL to connect to the data for the US. And this is the URL to connect to the data for Europe. So actually, I can have like two separate instances going to one to the Europe servers and another to the US servers, download the data, and so on. Now I'm going to show you the implementation of this batchlet. So as you can see here, I can inject the values that I defined on the XML. So the XML has these values defined, the US and the target URL. And I can inject them using the @inject annotation plus the @patch property and put the name of the property that I have on the partition plan. And then I can use these properties through the code. So since this is an offset patchet, I only have to override the process method. And what I do here, I just go and get the files from that realm, which is the server of the World of Warcraft. And since the files there are on JSON, on a JSON response or a REST request that I can do there, I'm using the JAX-RS client from Java E7. So I like this sample because it actually incorporates a lot of the Java E stuff. So I'm using this client here, pick up the target URL, get the response, then I just process and insert it on the database, and that's it. And if you can actually see here, I'm actually using also Java 8 using the Streams API. So this is also a fun example, so you can see how you can use Java 8 stuff as well. Now let's move to the chunk processing file. So what I've done here was just go to the servers and download a file or see the information of the file. So then I have another job called process file, which is going to like pick up the file, put it on an input folder, doesn't matter. But then I have something here called the process file, which is a chunk step. And then I'm going to process actually my data. So if I come here to this called action.item reader, what I have here is an open method, which I'm going to instantiate some of the stuff that I need, do some logging, get something from the context and so on, doesn't matter. And then my read item, since this is a JSON response that I get, I'm just going to use the JSON-P processing for Java E7 as well to get the data that I want and then transform it in some kind of object. So for you guys to have an idea on the format of the data, let me actually open something here.
So in the meantime, so you see that we are using GSR 352 on Java E, so we have a CDI that is provided by the platform. We have transaction, we have the JAX-RS client API, we have JSON-P. So, I mean, obviously you can do most of those stuff on pure Java EC, but by doing that on Java E, you have a lot of capability provided by default by the platform.
Yeah, that's the thing, because everything comes together and you have a very clear API where you can just blend all the things, and whatever thing that you want, you can just put it in. So this is an example of the response that you get. So this is a very small file. It's just only a sample file that I have here for some testing. So what you have here is the server, which I'm downloading the data, the options that I have there. So I have an ID, an item, the guy that's selling the item, a bid and buyout, so the values that are setting for the bids, or the values that I'm setting for selling the item right away, the quantity of the items that are being sold, the time left for the auction, and so on. So, okay. So this is actually going to read the item from the JSON file, so that's just an example. If I try to open a real sample of the JSON file, my ID is going to crash because it doesn't have enough memory to open one of the JSON file. It has around like 20 meg or something. And now, on the item processor, what I have here, I have an object called an auction. That's the one I actually, let me show you here on the item reader. What I'm doing here is just picking up the stuff from the JSON and filling up an auction type of object, which is actually a POJO, which is actually also a JPA entity. So I'm actually mixing JPA as well here. And on this item processor, I'm just filling out additional information that I have. So associating the realm or the server which the item belongs, and an action file, which means the original file which downloaded and originated these records. And finally, I want to write this data, and this is just as simple as picking up the list of the items I want and write them to Entity Manager, so not big deal. So this is one of the first steps. Then the second, I'm just going to do some import statistics. So what I'm doing is just picking up the raw data, putting it on the database. Then I'm just going to extract some statistics here. So I do the chunk again. And you can see here, this is a little bit different. On my open method, what I'm doing here is a JDBC query, which I'm doing some sums and means and so on. So I'm actually not doing plain open JPA or plain JPA here, because I want to do this as a scrollable result set. So I can just get one row each time and be able to do it on the item count of the chunk processing style. If I try to do it on JPA, I'm not able to do some kind of scrollable result set or something. Then I just read the item, go to the processor, and here I'm filling an object here called action item statistics, which is going to say what's the mean bid of the item, what's the max, what's the average, and so on. And finally, the the writer as well, which is only a plain write. This doesn't make any much sense if I don't have something to see, so I hope that I wasn't very quick with the code, but I actually built as well, let me put this a little bit bigger, if I can. Zoom in, oh yeah. So I built this really small application where you can just now come here, pick like a server, so I actually play this server, put an item here, so I'm not sure if this item exists, probably I think it should be because I have it here. Do a search, then I can see here the variation of the item that's here, and all the records that I just processed a while ago. So let's try to actually process something here. So I'm going to run something called the file job, the one that I told you that's connecting to the World of Warcraft databases. So what you see here is only plain log, which is pretty boring. But it's actually done. I'm also here using the parallel streams API from Java 8, and makes this a little more faster. And I'm going to run the process job, which is actually going to pick up the file and do something on it. So this takes a bit longer, but hopefully we're going to see a new point here after I refresh and after this is done. This is probably going to take like 20 or 30 seconds. Usually this is the time where I try to dance for the audience to entertain them, but I'm a bit injured on my knee, so I cannot do that. I'm really sorry for you guys.
It's okay.
Yeah, so it's done. And now if I come here on my web browser and I do another search, so see here, because you might miss it. Ooh. Let me see if I get, oops, no, I refresh. I should have another point there. No, I don't have this item, sorry. Let's try this one. Actually, 72092, yeah. Yeah, so if you see, one of the last processes I did was on April 9, was today at 1:47 p.m. And now the one I did now was at 4:53. Yeah, don't mind this because this is my local time, probably. But don't worry, this works, even if it doesn't seem to work. But that's it, pretty much. So now, returning again to our presentation. Let's have a look into some other features. David, do you want to do them? Okay.
Oh, I thought you were. You continue or?
Okay, yeah, I'll do it. Don't worry. So other things that we can do is that we can define the batch to work as a flow. So a flow is like a sequence of execution elements, where what we saw there was we have a chunk, we have a batchlet, but now we want to group them as a flow. So this means that we can actually execute all of these together as a unit. And this can include the flow, other flows, other steps, decisions, and splits. We haven't talked about decisions and splits yet, but we will shortly. They basically use it to aggregate like business logic. The split is something that you can do to have concurrent executions of a flow. So there, you can think of that as kind of as a partition, but it's not exactly the same, because what it's going to do is just going to fork your execution path, and it's going to execute two different things, while the partition actually executes the same thing, but using different data. But the same as partition, each flow runs on a separate thread. So to have an example here of the XML, so you have a split, then you have two flows, and then you can use them to run different business logic on each flow. So I'm pretty much usually use them to imagine I want to generate an export file and I want to do it, for instance, for a CSV and another for an XML. Then I can do a flow and say I want to do this using the logic to export it to a CSV file. Then I want to use this data and use an export to XML file or something. So that's one case I usually use a split. So partition versus split, in case you're wondering, because they are very similar. Usually partition, as I told before, is at the data level. So you're actually working with the same code, and you just partition using based on the data that you pass on the batch properties. And the split is used at, in my opinion, at the business level, where you just want to execute different logic when you're doing the flow. So decision. Decision it's used to decide when you want to do the next transition of on the XML file on your workflow there. It can be applied to steps, flows, and splits. And think of it as using like a if and an else if on your XML file. So it's pretty boring, but it's there and you can use it. It also requires you to use an implementation. Kind of like you have a reader or a writer, you also have to have something called a decider when you have to have your logic that's going to be there. So this is an example of decision definition. So just implement something called my decider. Yes?
I think we have an issue because the timer is crashed.
Really? Oh, well, actually I was looking into that. And
yeah, but it's 16 minutes since 10 minutes, so I don't know how we are doing in time. Ready? And we are supposed to end at?
I think it was 25?
Okay, so we still have
4 minutes, yeah. Yeah.
So it says 16 minutes?
Yeah, it says 16 minutes. So
10 or minutes, so...
Yeah, let's speed it up. And then decision is going to be just implemented and just put whatever you want to make the decision and you're done. Transitions we're going to skip. I guess they're not needed. You can look into them a little bit later if you like. Something interesting, of course, sometimes or most of the time you need to schedule a job. So there are a couple of ways you can do it. You can use, if you're on Java EE environment, you can use a singleton and you can use the @schedule annotation and just put the way you want to schedule your job. If not, you can also use managed schedule executor service, and you can do like a programmatic way to schedule the job. And that's it. So for the implementations that we currently have for the JSR352, we have the JBatch that's being implemented by IBM. That's a reference implementation, and that's being used by Glassfish and also Juice. And then we have the JBarrett, which ships with Wildfly, and of course Spring Batch. Now, actually, if you haven't looked into it yet, but they also actually have an implementation of their own for the JSR352. So if you're using Spring Batch, you can plug in the JSR352 API, and you can use both of them. And there's also Batch EE, which is a fork from JBatch with additional stuff. A few cons that I usually like to mention. The reference implementation does not have, they lack standard readers and writers, which means that, for instance, you want to read a CSV file or an XML file like you usually do on Spring Batch, where they have a lot of readers and writers available to you. You don't have them yet, but for instance, JBarrett already has them, but they are not standard. So that's something that I don't really like on the API. We're lacking generics. Actually, the generics are missing because the expert group didn't have enough time to put it in. Maybe they will appear in a future version. Partition only supports a single step, so you can only have one step per partition. There's also an open issue about this. And there is no synchronous mode, so that means that every time you put a job to execute, it's going to be run asynchronously. So you cannot get the result, wait for the result right away, so you have to query the batch operator to see if the batch is done or not. So these are some of the resources that we use. The specification. These Java E samples, which has a lot of not only batch samples, but also other Java E samples. But you can come here and see samples to partitioning, chunk, decider, and so on, with a lot of documentation as well. And you can find the sample I'll just demo here, the WoW Action House, and here on GitHub.
There's also the Java E 7 tutorial that you can use. So it's a free resources that go over all the Java E API, including the batch API. It's free, it's online, so just Google for it.
Yeah. And finally, me and David are going to be tomorrow, Friday 11:30, doing a lab for the batch. So if you're interested in learning a little bit more and trying on your own, you can come to our session and do this lab with us, and we will help you with anything that you need. So
we have 16 minutes left.
Yeah, 16 minutes left.
So,
any questions?
Yeah.
Can the partitioning be dynamic?
You mean like, so the question is partition can be dynamic? So you mean like writing your own partition instead of doing the XML stuff? And
yeah,
you can. So you can actually implement the partition as a class, and instead of putting it in a property file, you can just point it to the partition class, and you can do a lot of dynamic stuff there. I don't remember the exact API, but it's possible. Yeah. You can probably go on that Java E samples project. You're gonna find, and it was me that I've done it myself. But I don't remember the API, but you can find it there. Anything else?
Yeah, I have another question.
Yes.
When you have a retry on exceptions, can you have a wait on the retry? Like you just.
When you have a retry exception, if we can what? Sorry?
If you can wait.
Wait.
Do you have a parameter that said I will wait 2 minutes, 1 hour before retrying?
Okay, so the question is if when we have a retry, if we have some mechanism to wait for when we want to retry. So the mechanism is not built in, but nothing stops you to make your own mechanism to wait for something.
But you have hook in the life cycle of the job, so you can write your own code to do that.
There's something that we didn't cover here, which are but we will cover tomorrow on the lab, which are the batch listeners. And for instance, batch listeners is something that you can say, for instance, on retry, on skip, and when something is retrying, you can do some additional logic, and then you can probably put the logic there to wait for something. Any more questions?
So if you want to know more, comes tomorrow to our lab.
Or just grab us outside and ask us wherever you like. So guys, thank you so much for joining us.
Thanks.